Porch coffee. Bird feeders behind me, hummingbird feeder. They're starting to come back a little more. I messed up the feeders and mixed the juice for 2 feeders at the same time, so I've got to stagger them. But I also left them out too long and they got really moldy, so the hummingbirds stopped coming. Shame on me. But it's one reason I don't overfeed the hummingbirds. I don't want them reliant on a single source of food anyway. So surveys, that's what this one's about. Half a minute later. The notion of a survey, you have to go look in the dictionary to understand a survey. Oh boy, I got the shakes. It's chilly out here. More sun. I need more sun. So a survey is simple. Walk around and ask folks questions about something, the same something. That's a survey. It's that simple. It is that friggin' simple. A meter of any sort can be used for a survey. Now, what the survey means is a huge, good question, but that's how you can do a survey. So, one of the surveys, actually I've done 2 statistical surveys with my Geiger counter. One was of the stationary stability of the Geiger counter. Because it's a GPS location logging, I needed to know if I place the Geiger counter in a single place, how accurate is the GPS data. So what you do to test that is you go turn the meter on with fully charged batteries and you leave it somewhere stationary until the battery dies and the device stops logging. Now you have a record of every 6 seconds the meter logging a position. So you go bury that beside a railroad track for a day and you quote, watch the trains go by. And in that, you know it's a stationary data set, right? The variable is the trains going by. You have over 24 hours of background data, and then once in a while a train goes by. Unless you're watching for the trains or have some way of knowing when the train went by, you just buried the meter somewhere out of sight. And what you're looking for is a high meter reading. But if you don't know that a train went by, you have to have another way of go finding train times to correlate that back. But you have a hard time in a hard location, so you now have a survey. But my interest was, if I'm going to speak to one of these surveys, if I do find something, people are going to see a GPS map that shows that meter moving all over the place. So I took that million record log file, besides my own analysis, and sent it off for a peer review, a statistical analysis of the stability of that GPS reading. Because on a map it shows an area up to 2 or 3 city blocks is that meter having been there, and yet you know physically it hasn't moved. So that was a stationary sample for 2 things: GPS stability and do trains carry radioactive materials that this Geiger counter is capable of detecting. So the answer to the trains is no. My minuscule sample size, even though it's a 24-hour sample, an average of 8 to 14 trains go by that sample point a day. Actually, it's less than that. It's 4 to 6, it depends on the day. And you have to know the train schedule. And now you've left $1,000 meter buried by a train track. Unless you camped out by it, you are a little worried about your expensive meter. And you're worried about the data set, and you want to be able to analyze the data set to see what's there. So I've got a record. I've got multiple log records of GPS stability for that meter. And conversationally, you can tear the location data apart and say, oh, look, those are bad readings. So now you're going to have to take the notes from that reading that might exist somewhere and wonder if you've got an honest player. So this is the notes to these readings. This is metadata about a reading in the big data world, is part of a chain of custody record. This is all necessary to take your survey information out into public and have a conversation about it. This is the challenge. What does that mean? What does that scintillation Geiger-Muller tube, fairly well trusted instrument, tell me about? If I had gotten a high reading in a 24-hour time span and had gone back and traced the train out and its route, and it just hasn't happened yet. This is what's going on. This is the portion of the 8 minutes that doesn't cover much. There are random locations, there are random samples. And in some years of doing this, I haven't found anything yet to talk about. That's a random sample. These are samples, these are baseline information for tomorrow. I can go back after an accident and compare survey data. I have records of it. Safecast has records of it. And there are records stored elsewhere, just in case. So that's a simple survey conversation. That's one technique I mentioned, placing this device out by a high traffic area. And there's more places I do this. So, but it's random. And it's once a month, once every 2 months. It's when I'm curious. It's when I take the time to charge the meter up now, because until there's a reason to go looking for change. I have another statistical survey. If anyone's interested in the map, I'll put a link in down below. That I had the same analysis done. It's a moving survey. When the meter is moving, its logging is much more accurate. My theory behind that is the way the GPS chip is programmed. There's modes, methodologies inside of the GPS chip that define how well it works. And right now it's set up to be a moving detection device. So when moving, the device is highly accurate, but it will occasionally toss a reading out of line with wherever you drove. Remember, it's sampling every 6 seconds. So I just blew past my normal video time. My cigarette went out, my coffee's cold, and I'm still shaking, but thanks for listening.